Welcome to the bilingual e-lecture series for diploma students. In this session, we are going to see the system of forces and the problems related to the resultant force. It belongs to Unit 1 of Strength of Material subject for secondary mechanical engineering students. Now, we will go to the topic. There is a problem. Two forces A and B act on a stud as shown in the figure. Find their resultant. Use triangular law of forces. In the previous two sessions, we discussed a lot about how to find out the resultant force, what are the methods available, how to resolve the inclined forces into its horizontal component and the vertical component, and how to find out the magnitude of the resultant force and the angle between the horizontal. So, this problem specifically about usage of triangular law of forces. There are two forces A and B act on a stud as shown in the figure. Two forces A and B act on a stud as shown in the figure. So, we are asked to find out the resultant. Use the triangular law of forces. So, we go to draw the triangle and we go to find out the resultant force. What are the given data? A is given as 2 kilonewton, B is given as 3 kilonewton, and the angle between the two forces A and B is given by theta is equal to 180 degree minus 30 degree is equal to 150 degree. Okay. So, the angle between this is 30 degree, this is going to be 30 degree. Okay. So, 180 degree minus 30 degree, that is going to be 150 degree is going to be our theta. To find the magnitude and the direction of the resultant force using triangular law of forces. How to solve this one? Apply the law of cosine. Already we discussed in the previous sessions. Apply the law of cosines. How to find out the resultant? Resultant force R is given by square root of A square plus B square plus 2AB cos theta. Okay, here R square is equal to A square plus B square plus 2AB cos theta. We know the value of A, we know as 2, B we know the value as 3, then we know the value of theta as 150. It is a direct substitution. 2 square plus 3 square plus 2 into A into B into cos 150. So, this is going to be 23.392 kilonewton square. By taking the square root of 23.392, we will get 4.837 kilonewton. Since it has 3 digits, we can round it to 4.84 kilonewton. This is going to be the resultant force R's. So, we are having two forces A and B. Okay. The resultant force is calculated by using the law of cosines such as R square is equal to A square plus B square plus 2AB cos theta. Okay. By substituting the values for A, B and theta, we can directly get the answer as R is equal to 4.837. This can be rounded to 4.84 kilonewton. Okay. This is the magnitude of the resultant force. Then we go to find out the inclined angle. Okay. So, by applying the law of cosines, we have to find out the inclined angle. Sin theta by B is equal to sin 150 by 484. So, we can see the diagram. This is going to be O A B. It is 2 kilonewton and this is 3 kilonewton, and this angle is going to be 30 degree. This angle is going to be 50 degree. Okay. Now, we are going to calculate the angle between the horizontal and the resultant force. For that, we are going to apply the law of sines. According to the law of sines, sin theta by B is equal to sin 150 by resultant force. Okay, resultant force we have calculated just now as 4.84 Newton. 4.84 kilonewton. We have calculated as 4.84 kilonewton. So by applying the law of sines, sin theta is equal to sin 150 into 3 divided by 4.84, it will be around 0.31. So from this value we can calculate the value of theta as theta is equal to sin inverse of 0.31 is equal to 18.06 degree. What is theta? Theta is actually the angle between the force P and the resultant force R, but we have to calculate the direction of R with respect to the horizontal. So we are going to add the angle 15 with the theta. So the angle of inclination of the resultant force with the horizontal is given by 15 degree plus theta is equal to 15 degree plus 18.06 is equal to 33.06 degree. So the angle of resultant force with respect to horizontal is 33.06 degree. So the magnitude of the resultant force is 4.84 kilonewton. The direction of the resultant force is 33.06 degree. So in the next problem, find the magnitude and the position of the resultant of the parallel forces as shown in the figure. There are two forces P and Q which are parallel to each other. Okay, P has a magnitude 8 kilonewton, Q has a magnitude 8 kilonewton. P is 6 and Q is 8 kilonewton. They are separated at a distance of 100 mm. We go to find out the resultant force R. R is acting at a distance x from P. So given data, force P is given as 6 kilonewton, Q is given as 8 kilonewton and the length is given as 100 mm. To find the magnitude and the location of the resultant of the parallel forces, let x is going to be the distance, x is going to be the distance between the force P and the resultant force R. Okay. Since the forces are acting in the same direction, resultant force R is equal to P plus Q. It is nothing but P plus Q is equal to 14 kilonewton. Then we are going to taking the moment about to P. What will be the resultant moment? Resultant moment is equal to sum of all the moments acting on the object, P into O plus Q into L. Why it is 0? Because it is acting at the point P. It is acting at the point P. So now we are going to taking moment R into X. Okay, R into X is equal to P into perpendicular distance. What is the perpendicular distance? P is acting in this location only, so it is going to be 0 plus Q into L. We know the value of R and Q and L. Then we can easily determine the value of X. Okay, by substituting the values, we can easily determine the value of X. X is nothing but the location of the resultant force from point P. So the magnitude of the resultant force is 14 kilonewton and the location of the resultant force is 57.17 mm from point P. Now we will go to the third problem. In this problem, some forces are given. In the system of forces, we go to find the magnitude of the forces. Okay, in the system of forces, they are said to be in equilibrium. So we go to find the forces P and Q. So there are 5 forces acting on the object at a point and they are having unique included angle. By applying the equilibrium conditions, sum of all the horizontal component of the forces is equal to 0. Sum of all the horizontal forces is equal to 0. 4 into cos 20. Whenever we are going for horizontal cos, 4 into cos theta plus P into cos theta plus Q into cos theta plus 5 into cos 33 minus 5.5 into cos 50. Okay, we are having plus symbols for these 3 components and for 5 and 5.5 we are having minus sign. 5 and 5.5 because they are acting in the opposite direction. So they are acting in this direction. So it is going to be minus. All the 3 are acting in the positive direction. So we are going to have the positive value for those things. Then second continue. So using this method, now we are going to substitute the values. If you substitute the values, we can easily find out the value for P. Okay, P is given by 4.173 kilonewton. P is given by 4.173 kilonewton. Sum of f of x, all the horizontal forces, is equal to 0. So by using this condition, we can easily calculate the value of P. Then we go to find out the value for Q. Now we are going to apply another condition. What is another condition? Sum of all the vertical forces acting on the particle is equal to 0. So sum of all the vertical forces acting on the particle is given by 4 into sin 20 minus P into sin 18 minus Q into sin 90 minus 5 into sin 33 plus 5.5 into sin 50. Only 4 and 5.5 are having positive value. 4 and 5.5. 4 and 5.5 are having the positive value. 4 and 5.5. We have discussed all the upward forces are positive and all the downward forces are negative. So only these two forces are acting in the upward direction. So we are going to take the positive value for the two forces. So simply by substituting the values and by doing simple calculation, we can find out the value of Q. What is Q? 1.569 kilonewton. So the magnitude of the force P is 41.73 kilonewton and the magnitude of the force Q is equal to 1.569. So while taking the values for cos theta and sin theta, we should be very careful. For all the horizontal components, we have to take the cos values, and for the vertical components, we have to take the sin values. Then it will be easy for us. Okay. Now we are going to the last chapter of the unit 1, friction. So what is friction? What is a frictional force? The total frictional resistance between two contact surfaces is called as the frictional force. Okay, the total frictional resistance between the two contact surfaces. It is one contact surface, it is another contact surface. Okay, this is the object which is moving and this is the floor. We are having a slanting floor. Okay, the object is moving on the slanting floor. The total frictional resistance between the two contact surfaces is called as the frictional resistance. So there will be three forces acting on the object. One is the self weight of the object. It is nothing but the weight force which is acting downwards, Another one is the frictional force. It is nothing but the total fractional resistance between the two contact surfaces, and we are having one normal force which is perpendicular to the frictional force. What are the types of friction? First one is the limiting friction. The maximum value of frictional force which comes to act when a body just begins to slide over another body is known as limiting friction. So the limiting friction என்ன அப்படின்னா, ஒரு ஆப்ஜெக்ட் ஜஸ்ட் இட் டென்ஸ் டு மூவ், என்ன பண்ணுது அப்படின்னா ஸ்லைட் ஆகிறதுக்கு ட்ரை பண்ணுது. அந்த ஃப்ரிக்ஷனுக்கு பேர் என்ன சொல்கிறோம் அப்படின்னா லிமிட்டிங் ஃப்ரிக்ஷன். இட் இஸ் அட் ரெஸ்ட், இனிஷியலாக ரெஸ்ட்டில் இருக்குது. பை மீன்ஸ் ஆஃப் சம் ஃபோர்ஸ் இட் டென்ஸ் டு மூவ் ஆகிறதுக்கு ட்ரை பண்ணுது. அந்த ஃப்ரிக்ஷன் என்ன சொல்கிறோம்? ஃப்ரிக்ஷன் வேல்யூ இஸ் கால்ட் அஸ் லிமிட்டிங் ஃப்ரிக்ஷன். Next one is the static friction. Static friction is the frictional force offered by the body when it is at rest. Now the body is completely rest. It is in rest condition. Now we have to consider the frictional resistance. This resistance is called as static frictional force value. The next one is the dynamic friction. Dynamic friction is the frictional force offered by the body when it is in movement. When it is in motion, it is called as kinetic friction. It is also called as kinetic friction. When the object is at rest, ரெஸ்ட்டில் இருக்குன்னா அதை என்ன சொல்கிறோம்? ஸ்டாட்டிக் ஃப்ரிக்ஷன் சொல்கிறோம். ஆப்ஜெக்ட் மூவ் ஆகிக்கிட்டு இருக்கு, அதில் வர்ற ஃப்ரிக்ஷனல் ஃபோர்ஸ் என்ன சொல்கிறோம்? டைனமிக் ஃப்ரிக்ஷன் சொல்கிறோம். ஆப்ஜெக்ட் ஸ்டாட்டிக் ஃப்ரிக்ஷன்லேருந்து மூவ் ஆகிறதுக்கு ட்ரை பண்ணுது, ஜஸ்ட் இட் பிகின்ஸ் டு ஸ்லைடு, அந்த ஃப்ரிக்ஷன் என்ன சொல்கிறோம்? லிமிட்டிங் ஃப்ரிக்ஷன் சொல்கிறோம். தீஸ் ஆர் ஆல் த டைப்ஸ் ஆஃப் ஃப்ரிக்ஷன். Then what is the angle of friction? The maximum angle between the normal reaction and the resultant force of friction and the normal reaction is called as angle of friction. The maximum angle between the normal reaction and the resultant of the forces of friction and normal reaction is called as angle of friction. Usually there are three forces acting on the object due to friction. One is self-weight, another one is frictional resistance, another one is normal force. So the resultant of the normal force and the forces of friction and the normal reaction, இதுக்கு இடையில உள்ள maximum angle என்ன சொல்றோம் அப்படின்னா angle of friction அப்படின்னு சொல்றோம். Next one is mu. What is mu? Mu is nothing but coefficient of friction. Coefficient of friction is the ratio between the limiting friction to the normal reaction between the surfaces in contact. Coefficient of friction is nothing but ratio between the limiting friction to the normal reaction between the surfaces in contact. This is called as coefficient of friction and it is denoted by the symbol mu. It is called as mu. It is denoted by the symbol mu. Next one is the important terminology, cone of friction. Okay, when the resultant reaction R is rotated about, when the resultant reaction R1 is rotated about the normal reaction R, a cone is generated with a vertex angle 2f, with a vertex angle 2f. The semi vertex angle f is called as the cone of friction. The semi vertex angle f is called as the cone of friction. So we are having a resultant reaction R1. The resultant reaction is rotated about the normal reaction to 360 degree. When the resultant reaction R1 is rotated with respect to the normal reaction with respect to the point P to 360 degree, a cone will be generated, okay, with an angle of 2f. This angle is called as cone of friction. This angle is called as cone of friction. So what are the laws of static friction? The direction of frictional force is opposite to the direction in which the body tends to move. So the direction of movement of the object is opposite to the direction of frictional force. Okay, the frictional force resists the movement of the object. So the direction of the frictional force is always, you imagine a object tends to move in this direction. Frictional force, what about the frictional force? The frictional force tries to stop the movement of the object. So it always acting in the opposite direction. The frictional force depends upon the material of the bodies in contact. What is the nature of the material of the contact surfaces? That is very important. Okay, the frictional force depends upon the material of the bodies in contact. The force of friction is independent of the area of contact between the two surfaces. Okay, the force of friction is independent of the area of contact between the two surfaces. What is the area in contact? That is not important. What is the material of the contact surfaces? That is important. So this is for static friction. For the dynamic friction or kinematic friction, what are the laws? The direction of frictional force is opposite of the direction in which the body tends to move. Similar thing. The magnitude of the kinetic friction bears a constant ratio to the normal reaction between the two surfaces. The magnitude of the kinetic friction bears a constant ratio to the normal reaction between the two surfaces. Then at lower speeds, the force of friction remains constant, but at lower speed the force of friction remains constant, but it decreases at higher speeds. Whenever the speed of the object is increased very high level, okay, the frictional resistance becomes almost negligible. These are all the laws related to the dynamic or kinematic friction. Now we are going to see how to determine the frictional force acting on an object. Okay, so here we are seeing a picture which shows a ladder. Okay, the ladder is positioned between point A and C. The ladder is positioned between point A and C. Okay, it is placed inclinedly between the floor and wall, where AC is the length of the ladder, where AC is the length of the ladder, and AB is the height of upper end of ladder from floor. AB is the height of the ladder, upper end of the ladder, height of the upper end of the ladder from floor. Then BC is the distance of the lower end of the ladder from wall. C is this location. So, from the wall, what is the distance, lower level of C? This is going to be BC. Then W is nothing but self weight of the ladder acting at the center of the ladder. Okay. W is the self weight of the ladder due to the gravitational force. Okay. The self weight of the ladder will act at the center of the ladder. It is given by W. CD is equal to BC by 2. Usually CD is given by BC divided by 2. Okay. The point of application of self weight will be at the mid of the ladder distance. What is the ladder distance? Distance between B and C. What is RC, RA or FC? RC is the reaction at the foot of the ladder, RA is the reaction at the top of the ladder. You imagine this is the ladder position. So, RC is the foot of the ladder, reaction at the foot of the ladder, and RA is the reaction at the top of the ladder. FC is the force of friction between ladder and the floor. FC is the force of friction between the ladder and the floor. RC is the reaction acting at the point C and RA is the reaction acting at the point A. What is FC? Force of reaction between the ladder and the floor. What is FA? Force of reaction or frictional force acting between the ladder and wall, ladder and upper end of the ladder and wall. FC is always equal to RC, FA is equal to RA. For right angle triangle ABC, by using the Pythagoras theorem, we know that AB square equal to AC square is equal to AB square plus BC square. So, by using these values, okay, we can easily determine the frictional resistance. This is going to be our diagram. A, point C, point B. This is our ladder. This is the wall. This is the floor. Okay. By using the Pythagoras theorem, okay, AC square is equal to AB square plus BC square. What is sin alpha? AB by AC, cos alpha BC by AC, sin theta BC by AC and cos theta is equal to AB by AC. Then what is mu c? Coefficient of friction between ladder and the wall. Mu c is the coefficient of friction. Here we are having some coefficient of friction. Similarly, here we are having some coefficient of friction for the frictional resistance. So, the coefficient of friction at point C is mu c and the coefficient of friction at point A is mu a. So, due to the self weight of the ladder, we can calculate the resultant forces for both smooth vertical walls and rough walls. Resolving forces vertically, RC is equal to sum of loads on ladder and RC is equal to W. What is W? It is nothing but the self weight of the labor. Resolving forces vertically, RA is equal to FC, RA is equal to RC. Reaction at A and reaction at moment of all forces about C. We can take the moment about any point RA into AB is equal to W into CD. This is for smooth vertical wall and this is for rough wall. For the rough wall, we go to take the frictional resistance. Okay, for the rough wall, we go to take the frictional resistance. Now we are going to see similar kind of problem where another weight is added to the ladder because of a man climbing on a ladder. A new weight W1 is added to this location due to a man standing on the ladder. He is climbing on the ladder. The weight due to the man is given by W1, all others are same, and the point ED is nothing but the point of intersection of the W1 at B and C. So, this is the formula to calculate the reactions and the frictional resistance due to the frictional force arising at the points. This is for smooth vertical wall and this is for rough wall. Okay. Whenever we came across rough wall, we go to include the frictional resistance also. A uniform ladder weighing 20 Newton and having a length 10 meter is placed against a smooth vertical wall. With its lower end 8 meter away from the wall. In this position, the ladder is just to slip. Determine the coefficient of friction between the ladder and the floor, frictional force acting on ladder at the point of contact between ladder and floor. என்ன கொடுத்திருக்காங்க, ஒரு லேடரோட வெயிட் எவ்வளோ கொடுத்திருக்காங்க, 20 நியூட்டன், லென்த் கொடுத்திருக்காங்க 10 மீட்டர். எது மேலே வச்சிருக்கோம், ஒரு ஸ்மூத் வெர்டிக்கல் வால். எவ்வளோ தூரத்தில் இருக்குது, லோயர் எண்ட் 8 மீட்டர் அவே ஃப்ரம் த வால்ல இருந்து 8 மீட்டர் அவே பண்ணியிருக்காங்க, தள்ளி இருக்குது. ஓகே, it is kept at a distance 8 meter away from the wall. Okay, you look at the picture. Okay, 20 newton self weight 8 meter away from the wall. So for the smooth vertical wall, these are all the given data. AC is given, okay, 10 meter, load weight W is given as 20 newton, BC is given as 8 meter. We go to find friction A, coefficient of friction between ladder and the floor, frictional force at C, mu C, Fc and mu A. Coefficient of friction between ladder and the floor can be determined by using this method. Taking moment about all the forces acting about the point C, RA into AB is equal to W into CD. RA into AB is equal to W into CD. W is nothing but self weight, R is the reaction at A. From this we can determine the value of CD. So CD is determined. Now we go to find the value of AB. AB is given, calculated. AB can be calculated using the right angle triangle ABC. Triangle ABC, we can easily calculate the value of AB. What is RA? RA is equal to, since it is a smooth vertical wall, RA is equal to FC. FC is given by mu C into RC. This is equal to mu C into 20, and RC is given by weight W. This is nothing but self weight of the ladder, 20 Newton. Now RA into AB is equal to W into CD. Therefore, by substituting these values, mu C into 20 and W into CD, we can determine the value coefficient of friction, mu C is equal to 0.667. The frictional force on the ladder at C can be calculated using the formula Fc is equal to mu C into Rc. Mu C is the coefficient of friction between the ladder and the floor, Rc is the reaction at C. By substituting these values, we can easily determine the frictional force on ladder at point C as 13.33 Newton. Okay, what is the result? Coefficient of friction between ladder and the floor, mu C is 0.67. Since it is a coefficient, it has no unit. Okay, frictional force at C is given by 13.33 Newton. So with this, we are coming to the end of the session. In this session, we discussed about some problems related to determining the resultant forces and their angle, and we touched upon the topic friction and what are the types of friction, what are the terminologies related to friction, and we solved a problem related to the ladder. So with this, we are closing this session and we will continue in the next session. Thank you.